Welcome everyone to this demo to create a multi-master cluster using Kubeadm. As a part of this demo, we'll use something called as a Kubeadm utility to create a multi-master setup for Kubernetes. As a part of this setup, we'll have two masters, two workers, and we'll have one additional node that will act as a load balancer for both the masters. Before we even start off with the demo, let's do a quick introduction to what is Kubeadm. Kubeadm provides you with a utility, or Kubernetes provides you with a utility called as Kubeadm to initialize and join your cluster. So in a way, it is a bootstrapping utility, and it helps you create a single master cluster, a multi-master cluster, and it takes care of making sure that the cluster that you create, it passes all the conformant tests that are given to us by Kubernetes. So if we take a look at this GitHub repository over here that we'll use to create a cluster, and I believe now we can start off with the actual demo on how to use Kubeadm to create a multi-master cluster. First of all, let's talk about prerequisites. As a part of prerequisites, we will talk about what sort of virtual machines do we need and what should be the corresponding sizing, OS version, and so on. First of all, we need two virtual machines for the master. The machines needs to be at least Ubuntu version 16.04. We'll be using Ubuntu as a primary OS. It needs to have 2 CPU, 2 GB RAM, and 10 GB storage. The second machine that we need two additional machine for the worker nodes. Once again, similar configuration, Ubuntu 16.04 plus, one CPU, 2 GB RAM, and 10 GB storage. So the master needs to have at least two CPU, and the worker can work with a single CPU. The load balancer machine will have exactly the same configuration as the worker nodes. So once again, Ubuntu 16.04 plus, one CPU, 2 GB RAM, and 10 GB storage. Apart from that, all the machines they need to be in the same network. That means the machines need to be accessible from each other. In case if you're using any sort of cloud provider, just make sure that they are within the same VPC. The machines, or you also need to set up SSH connectivity between at least one machine. And for our demo, we'll use load balancer. So the load balancer will have the actual private key, and the public key can be distributed across all the corresponding master and the worker nodes along with the load balancer node itself. We are not really going to have a demo on how to create SSH keys. I'm assuming that you already know how to set up SSH keys either on the virtual machines or on top of your cloud provider. You also need to have sudo privileges. That means you should be able to log in as root. And you need to set up SSH connectivity between the load balancer node and the master and the worker nodes. Something that is not a prerequisite, but it's good if you have it because you will need to copy over certain files at the end of the demo. So rather than downloading the file from a virtual machine and then uploading it to the load balancer node, might as well set up SSH key beforehand. It will help you a lot in case you want to set up your own certificates. Once again, certificates are not something we won't cover over here. We'll only use a certificate given to us by Kubeadm. So now that we have talked about the prerequisites, let's take a look at how my cluster looks like. So I have one load balancer node and two master nodes and two worker nodes, as you can see. Load balancer and the worker node, they have the same configuration, that is one CPU, 2 GB RAM, 10 GB storage. The master node over here has configuration of two CPU and 2 GB of RAM. The OS that I'm using is Ubuntu version 18.04, and I already have SSH setup between the load balancer node and the master and the worker nodes. So if I quickly go to my load balancer node over here, as a part of my load balancer node, I can do a quick SSH test by just running a simple script. So for I in master 1, master 2, worker 1, worker 2, and load balancer node itself, do $i hostname to just verify if I can connect to all the machines using the DNS name. And that would also prove that I have network connectivity between my load balancer node and all the other master and the worker nodes itself. So all the nodes, they are within the exact same network of US West 1. So now that we have established the fact that I have my clusters, I have my machine set up and I do have SSH connectivity, we can start off by setting up the load balancer. First and foremost, why do you need the load balancer node? The load balancer node is required to load balance between both the masters, which means that now that you have two masters, if you as an end user ever wanted to fetch some data from Kubernetes, for example, you just wanted to run a simple command like kubectl get pods, how do you exactly execute it? Are you going to execute it on the master, or are you going to tell Kubernetes that I want my output from, let's say, master 1? That's not really going to be the case because your server right now, your cluster right now is highly available since you have multiple masters. The load balancer helps you in load balancing your request, or not just your requests, even the requests coming from your kubelet, and will distribute it across both the masters. And that's the primary reason why you would need to have a load balancer node. Now, the other question is, what sort of load balancer should you use? If you're working on top of a cloud provider, feel free to use your TCP load balancer. You can create a simple TCP load balancer on your cloud provider, and you can still use the same load balancer as a part of this demo. If not, if you want to create your entire cluster on premise, then you would need to leverage certain tools, certain load balancing tools like a F5 load balancer, A Proxy. Even a simple proxy pass using Nginx or Apache should also be fine for this demo. So as long as you have any utility that you can use to create a load balancer, that utility should be completely acceptable. As long as you have a front-end configuration and a back-end configuration, that's the only thing that you need. For this demo, we will be working with A Proxy as our primary load balancer. However, there are multiple demos available on the internet where they use Nginx, someone uses F5, and some other people also use the cloud-based TCP load balancers. So let's now start off by configuring our load balancer server, and we'll now install A Proxy. So first of all, let's log into our load balancer server, and we'll switch to root first of all, because we'll be performing the entire demo as root. So once we have switched to root, we'll then run an apt-get update and apt-get upgrade. Now this usually takes some time, so I'll pause my screen in between till the time the entire upgrade has taken place. So let me just log into my load balancer server first of all. I am at my load balancer VM. I'll clear my screen so it is visible to everyone. And now I can start off by running my first few set of commands. I'm already logged in as root, so sudo -i I have already run using my own ID. And now I can run the second command, that is apt-get update and apt-get upgrade with a -y flag, so that I don't have to type ps after every whenever I prompted to. So I'll go to my load balancer node and just paste this command. And this will take a couple of minutes. So I'll pause my screen right now and I'll start as soon as the upgrade has taken place. As you can see, I got my prompt back and the upgrade is now complete. So that means I can just clear my screen over here so that everybody can see the next set of commands that we'll run. We'll go back to our GitHub repository and we'll run the next set of commands. So now that we have run the upgrade, we'll now start off by installing A Proxy, and then we'll configure the A Proxy to set up our front-end and the back-end configuration. To install A Proxy, we'll just run the command apt-get install A Proxy with the -y flag. We'll take this command over here and we'll go back to our load balancer node, and we'll paste the command so that A Proxy gets installed on our server. A Proxy is now installed. I've got my prompt back, and I can just clear my screen over here so that we can run the next set of commands. So now that we have installed A Proxy, it's now time to tell A Proxy that what should be load balanced. So now we'll edit one configuration file, that is etc proxy haproxy.cfg. I'll just run this vi command. If you're not familiar with vi, you can use any other utility of your choice like gedit, nano, and so on. And I'll go right at the end of the file so that I can start adding my configurations. So I'm right at the end of the file over here. And we'll go back to my GitHub repository to understand what configuration are we actually going to put. As a part of load balancer or any load balancer, even if you're using load balancers on top of cloud providers, you always have two configuration. The first configuration is called as a front-end configuration, where you tell your system that where will the incoming request come to. So the incoming request can come from anywhere, can come from anywhere to my system, that is 0.0.0.0 at the port 666443. Sorry. So the bind configuration is 0.0.0.0. That means my own system, my machine, that is my load balancer server, at the port 6443. Now why 6443? Because 6443 is the default port for API server. As part of architecture, we know that only the API server is the primary front end for the entire master control plane, which means that the only component that we need to load balance is the API server. And API server, the default port is set as 6443. The mode we are going to keep it as TCP. Now the default backend is a location that tells the front end server that where to route the request to. The default backend, we are giving it a name called as BE-API server, that is backend-API server. And the backend API server configuration is written right below the front-end configuration. That is the backend server BE API server. The mode once again is TCP. Then we have certain more additional flags that is required by our HA proxy configuration. The algorithm that we'll use is round robin. So it is going to use round robin algorithm to load balance between both the masters. And then we have the details about what are the servers that we are going to use. So server is master1, master2. That is a DNS name for my server. And then I have the corresponding internal IP address. So typically true when people are using cloud provider, you already usually have a combination of internal IP and an external IP. That is a private IP and a public IP. Always use the private IP address. It is much more secure. You don't really want to use a public IP address and let your connections flow through the internet. Once again, the port will be 6443 because master and master 2 are the location where your API server will actually run. Unless you want to configure a different port for your API server, I would suggest use a default port that is 6443, and it will also perform a check at the corresponding port and the IP address. So these are the front end and the back end configuration on how you would set up your load balancer. So we can take the front end configuration from here, and we'll go to my load balancer server, and I'll just paste the configuration at the end of the file. And then for the backend configuration, I'll once again go back to the GitHub repository, take the backend configuration, and I will paste the configuration right below the front end config, right over here. Just one small note over here is that in case if the name of your servers are different, make sure you're using the DNS name or the host name of your server itself. In my scenario, the name of my server is master1, master2. Probably the name of your servers would be slightly different. So whatever server name that you have and whatever IP address that you have, make sure you change the configuration for backend and ensure that you're writing the correct configuration. That means the correct host name and the correct IP address. Make sure that you are making the corresponding changes and changing the value to fit your configuration. So now that we have added the front end and the back end configuration, I can go ahead and I can save this particular file. I'll save this file over here. And that's about it. I do not have to do any other changes at this point of time. So now that I've edited my configuration, I can just go ahead and I'll restart HA Proxy so that it takes in all the configurations, all the latest configurations that we have added. So to restart HA Proxy, we'll run the command systemctl restart HA Proxy so that the HA Proxy gets restarted. I'll take this command and I'm just going to paste it on my load balancer node. And this restarts HA Proxy. And the next command is to just view the status of the HA Proxy node so that it gives us either a running or a failed status. And as you can see, HA Proxy over here is an active status at this point of time. So it's active, it's running, and it has started all the front end and the back end API server configuration that we have actually wrote in the HA Proxy CFG file. So we can just enter Q to quit from this attachment that happens after you run the systemctl status command, and I'll clear my screen so that everybody can see the next step of the commands that we'll write. We'll go back to our GitHub repository page, and we'll just run one more command with the nc command, the netcat command, to see whether or not we're successfully able to attach to a server or not. So we can take this command nc-v to localhost, that means the host on load balancer node itself, at the port 6443. We'll go back to the load balancer server, and you should ideally get an output stating that the connection to the localhost at the port 6443 has succeeded, which means 6443 at this point of time is now active, is now serving incoming requests. So now that we have installed the load balancer, it's now time to configure the master and the worker nodes. For the master and the worker nodes, there are certain components that you have to install. And these components are Kubeadm, the executable itself, kubelet, and Docker. So the kubelet, Kubeadm, and the Docker binaries have to be installed on all the nodes. That means it needs to be installed on master 1, master 2, worker 1, and worker 2, not on load balancer. Load balancer configuration is almost complete. We'll keep the load balancer node aside, and now we'll start installing the remaining components on master and the worker nodes. Once again, whatever steps that we run as a part of this demo should be run on all the nodes. I will be running the demo on one of the master, either master 1 or master 2, and then you can replicate the exact steps across all the 4 nodes. So I'll be showing you how to run these steps on one of the masters, and then you can replicate the exact same steps, exact same commands on all the remaining nodes. So let's start off by logging into one of the master, and I'll be taking in over here master 2 as the primary master that I'll be working with. In master 2, you just have to log in as root, and after logging in as root, you have to run some sets of command. So first of all, we'll start off by running a simple apt-get update to update the current repository. So I'll take the command, run it on master 2. I got my prompt back. That means apt-get update has completed successfully. I'll clear my screen. I'll go back to my GitHub repository, and next step is to turn off swap. Turning off swap is one of a prerequisite for Kubernetes itself. That means kubelet configuration requires swap to be turned off. So we'll turn off swap on master 2. Then we'll start installing Kubeadm and kubelet. There are certain steps of command that we have to follow. First of all, we have to install certain OS-based dependency. That means we have to install certain packages like app transport HTTPS and curl utility. So we'll take the first line of command. We'll just add it. We'll just run it on our master 2 system. And it should install both the utilities, that is app transport HTTPS and curl. I'll clear my screen over here. And we'll go back and now we'll start installing the two components, that is Kubeadm and kubelet. To install Kubeadm and kubelet, we first have to download a GPG key required for authentication, and we'll run the curl command to install the GPG key on our system. You should get an output called as OK. OK means that the GPG key that you have downloaded is now successfully registered in your system. The next step is to add the repository detail for the location from where you'll download the Kubernetes binaries or Kubernetes packages in your etc apt sources.list. So we can take the next set of commands, that is 3 lines over here from cat till eof, and we'll paste it on our system. This basically creates a single file, and the name of the file is at the first line itself, that is etc apt sources.list.d, and inside this directory you will create a file called as kubernetes.list. Run a simple cat command to see that the output is nothing but the second line that you have entered. That means this is the location from where you're going to download the packages required to install Kubeadm and kubelet. We'll go back to the repository and we'll run a simple apt-get update to update the latest repository detail that we have given. And the update command will add the latest repository from the new file that you have created, and will update its cache with all the new repositories that it must have found from the etc apt sources.list.d. And finally, we'll run the command apt-get install for kubelet and kubeadm. This usually takes more than a couple of minutes, so I'll pause my screen and I'll just start my screen back once the installation is completed. So I'll run this command on my system. I've got my prompt back, which means Kubeadm and kubelet are now successfully installed. I'm just going to clear my screen. And now we can run one last command that is apt-mark to hold the kubelet and the kubeadm binaries. So we'll run this command and this will hold a kubelet and kubeadm. Now that we have installed Kubeadm and kubelet, it's now time to move to the next set of instructions, that is to install the Docker component. We have taken the Docker installations directly from the docker.io website, directly from the installation steps. So something that you can actually refer to in case if you want to install any specific version of Docker. So we'll install the latest version of Docker, that is 19.x, whichever will be the latest minor version. We'll start off by running a simple apt-get command so it can install any prerequisite packages. So we'll take the apt-get install command for all the prerequisite package. As you can see, a couple of packages are already pre-installed when we wanted to install Kubeadm and kubelet. However, it's completely fine. We can rerun the package. It won't do anything to the already installed packages. So we'll take the apt-get install command till the software properties common, and we'll run it on the master 2 that we have been working on. And as you can see, everything is now installed. I can clear my screen once again. Go back to the repository, and similar to how we installed Kubeadm and kubelet, we'll follow almost similar steps, that is adding the GPG key, adding a repository, running an update, and then installing the corresponding Docker packages. So we can start off by step number 3, sorry, that is to add the GPG key. We got OK as an output. Next step is to add the repository details. We'll take this, we'll just paste it. This adds the repository details. Next step is to run an update. This will update the current repository with the latest repository of Docker. And then finally, we'll execute the command apt get installed for Docker CE, that is a community edition, along with the CLI and container D. So we'll take this, we'll execute it on our system itself, which installs almost all the packages required for Docker. Now, once again, this takes around a minute or two to complete, but I'll pause my screen in between. However, once again, guys, all these steps, they have to be performed on all the nodes. That means on master 1, master 2, worker 1, and worker 2. I'm showing you only on master 2. However, these commands they need to be run on all the nodes itself. As you can see, my installation is almost complete. It's actually complete. I got my prompt back and I have successfully completed installation of Kubeadm, Kubelet, and Docker on master 2. Now we'll start off by installing them on master 1, worker 1, and worker 2 nodes. So I have now completed the installation on all the 4 machines. That means I've completed installing Kubeadm, Kubelet, and Docker on master 1, master 2, and my worker 1 and worker 2 nodes. So now that we have all the components installed, it's now time to bootstrap the cluster. And to bootstrap the cluster, we first have to start off with any one of the master, any master of your choice. You can either choose master 2 or you can either choose master 1. I'll be starting off with master 1 as my primary master. I'll first initialize my cluster on master 1. And to initialize the cluster, you have to run a command called as kubeadm init. The kubeadm init command is used to initialize a cluster. It basically takes in certain flags. And the flag it takes is called as a control plane endpoint flag. The control plane endpoint flag needs to be the value of your load balancer server DNS. So I'll be using the host name load balancer. In case if you do not have access to the load balancer using the host name, feel free to use the internal IP address as long as the load balancer is able to connect to master 1 and master 2 both. A DNS name, host name, or even IP addresses should be completely fine. Along with the IP address or the DNS name, you also have to add the port of the load balancer that you have specified in the front end configuration. So in my scenario, I had specified the port 6443 because that is the default port of the API server. So in my case, the entire value of the control plane endpoint flag would be load balancer :6443. However, you can also use the IP address in case a host name is not directly accessible to you. So once again, we'll be using the Kubeadm generated certificate. So we will use the flag called as upload certs. And then the third flag that we'll provide is the pod network CIDR flag, which tells Kubernetes that what will be the pod network CIDR. That means what will be the IP address or what will be the CIDR or the subnet on top of which the IP addresses will be assigned to the pods. The reason why we are using 192.168.0.0 by 16 is because I want to use Calico as my primary CNI. And if you're not aware, then Calico's default configuration for pod network CIDR is 192.168.0.0 by 16, something that can be configured. But if you want to configure the Calico CNI to a different range of IP address, you will have to make the changes in this location. That means you have to make the change while initialization itself, and then you can make the change in the corresponding calico.yaml file. But for now, for the purpose of for the sake of this demo, we are going to use the default CIDR provided by Calico, that is 192.168.0.0 by 16. So once again, we'll be running this command only on one master. Now, please note that this command will generate a series of outputs, and these outputs are something you have to preserve because they will contain commands that you will have to run on worker nodes on the master 2 node, as well as the command that you need to run on your load balancer node. So it is going to generate a series of outputs. So make sure you preserve the output. Once you run this command, do not clear your screen. Preserve the output on master 1 because that will become a reference to what is to be executed on master 2, worker 1, and worker 2. So we can start off with this demo and I'll pull up my master 1 node. So my master 1 node is right over here and everything is once again installed on master 1, master 2, worker 1, and worker 2. That is Kubeadm, Kubelet, and Docker. I can take this command over here, that is Kubeadm init control plane endpoint, and the value in my case will be load balancer :6443. upload cert and the pod network CIDR will be 192.168.0.0 by 16. I can take this and I'll run this command over here so that it initializes my cluster. So I got my prompt back, which means that my initialization is now complete. As a part of my output, I get three major scenarios. The first thing it gives me is how to configure my kube config, which is pretty similar to how the kube config would be configured even on a single master cluster. The second thing that it provides me is the way to bootstrap other master, that means other control planes, as a part of my cluster, which means that I can run the Kubeadm join command on master number 2. The third thing that it provides us is with one another command that is going to bootstrap your worker nodes to the master 1 and the master 2 control plane. So if you take a closer look at what is really happening, is that step number 1 is something that I have to run on the load balancer node. The step number 2 is to join the master number 2. However, the bootstrap node will be the load balancer at the port 6443, which means that the join command is not for master 1, it is for the load balancer node. And the second join command that you see over here is once again joining to the load balancer node. That means all connectivity, all communication that will always happen through the load balancer node at the port 6443. We'll start off with step number 2. We won't start off with step number 1 right now. We'll create the kube config right at the end. However, I'm going to keep my screen as it is because this particular data is important for me because I have to take it and paste it on my master 2 and my worker 1 and worker 2 nodes. So I can start off by joining my master 2 as a part of the same control plane. I can take the command that is kubeadm join load balancer 6443 along with the discovery token and the control plane token. So that means all of you guys, whoever has completed this demo, can use their master 1 node as a reference, and you can take this command and you can paste it on master 2. So I'll go to my master 2 once again, logged it as root. I'm going to paste it over here so that it starts off with the prerequisite check and will then bootstrap the master 2 as a part of the same control plane. So as you can see, the master to join command is now complete, and the output that I get over here is that a node has joined a cluster and a new control plane instance has been created, which means that this master 2 has now joined my cluster as a separate control plane, which is communicated through using the load balancer and the port 6443 that we have configured on A Proxy. So I can go back to my master 1 once again, and I'll take the command to join the nodes. That means I'll take the last command, that will be the exact last command on your screen, kubeadm join load balancer colon 6443 and the corresponding token and the discovery token CA cert. I can take this command, I'll go to my worker 1 and I'll execute this command on worker 1. Similarly, I'll go to worker 2 and I will execute the exact same command on worker 2. I'll go back to my worker 1 to see what is happening, and as you can see, my worker 1 has now joined my master, and my worker 2 once again should give you a similar output saying that the worker 2 once again has now joined the master. The node has joined the cluster and some information about the certificates and what the kubelet and how the connection to the kubelet happened. And it gives you output saying that run the kubectl get nodes command on the control plane to see if the node has joined a cluster or not. So just for time being, just to verify if everything worked correctly or not, I'm going to take these three lines. That's mkdir-p, that is to create a .cube directory, copying the admin.conf as config file inside the .cube directory, and changing the ownership. I'll just execute this on my master one itself. So I'll take these three commands I will just execute it on the master over here so that I have my master setup to just run a couple of commands for verification. Now I can run a command called as kubectl get nodes to see what is really happening. So kubectl get nodes to quickly verify whether or not all the servers, that is master 1, master 2 and worker 1, worker 1, worker 2 are bootstrapped or not. And as you can see the output over here, I see that all the four nodes, that is two masters and two workers, are now combined as a part of the same cluster. Even though the status is not ready, it will become ready once we install Calico on our system. So now that we have initialized the master, joined the master 2 as a part of the control plane, and joined the worker as a part of the entire cluster itself to work as worker nodes, we can now start off by basically configuring the load balancer node. To configure the load balancer node, we'll use the exact same commands or similar commands to what we did to configure master 1. We'll go back to the load balancer server once again, logged in as root, and now we'll start off by running the first command, that is to create a .cube directory at the home location. We'll run this. That's it. This creates a .cube directory on my home. So now that I have the .cube directory set up, the next thing that I need is basically to copy over the admin.conf file. I'll copy over the admin.conf file from master1 and I'll save it as a file called as config inside the .cube directory, which means that since I already have SSH set up, I can basically run the command scp from master1 and I'll give the path of etc kubernetes admin.conf and I'll store it at my current home location, that is $home slash .cube slash config. So basically I'm just replacing cp-i with the scp command. In case you do not have SSH setup, you can just download the admin.conf file and you can upload it to the load balancer node and you can basically rename it with the name as config inside the .cube directory. And this should copy over the file. So I can go inside cd.cube. Inside cd.cube, I should find the admin.conf file renamed as config. And finally, I can give the corresponding ownership. That is, I'll change the ownership to root, which is ideally already there. But however, if you're really not using a root user, you'd probably want to change the ownership in case you're using a non-root user. That means your own account. And I now have config setup on my load balancer node. So let's go back to our GitHub repository and we have almost configured the entire cluster. We can scroll down to the steps that we have actually completed. We'll scroll down to configuring the kube config on load balancer node. We have completed these commands, that is creating the .cube, copying over the admin.conf to the corresponding location on the load balancer node. And now that we have also changed the ownership, it's now time to install the Cubectl CLI. Cubectl CLI is a primary CLI that you will use to interact with Kubernetes. There are multiple ways to install CLI. We will use snap over here in order to install CLI, which is a pretty fast way to install any binary. So we'll use snap install kubectl -f classic to install the kubectl binary on the load balancer node. So I'll clear my screen and I will run snap install kubectl -f classic. It gets the latest version of kubectl and it installs it. Now we can run the same command that we ran on the master as well as the worker nodes. We'll run kubectl get nodes to see if whether or not we are getting the corresponding output or not. This means that since we are getting the output, that means load balancer is functioning fine. It is load balancing between both the masters and giving us the corresponding output. And the final step over here will be to install the CNI, and the CNI that we'll install is Calico. So over here, we're installing the version 3.8 of Calico. However, you can install any CNI of your choice. Since we have already kept our pod network CIDR as 192.168.0.0 by 16, which is the default pod network CIDR defined in the Calico YAML, we don't have to make any updates. But in case if you have already made any update to the pod network CIDR, you can just download this calico.yaml file on your local system using a simple wget command. Edit this file, change the pod network CIDR, and then run the same command kubectl apply with the location on your system where your calico.yaml was downloaded. I don't want to make any changes, so I'll just run the same command kubectl apply -f and the network location of the calico.yaml file. It creates a bunch of entities in your system, some custom resource definition, and it creates your cluster role bindings, and deploys the actual Calico pod. It actually runs as a daemon set. However, you will have at least 4 pods running in the system. So I'm going to clear my screen. We'll just quickly run a command kubectl get pods -n cube-system to see what is happening in our system right now. I see that a lot of pods are running. Some are getting created, some are getting initialized. I'll just wait for a couple of more seconds to see if everything is running or not. Almost everything is running right now. One pod to go. And that's about it. I'll clear my screen. I'll run the command once again, kubectl get nodes, to see whether or not all the master and the worker nodes are in ready status or not. And at this point of time, our installation is now complete, which means that we have successfully configured a multi-master configuration, a multi-master cluster using Kubeadm. One final thing that we'll do is we'll just run one simple pod nginx and we'll see how we'll be able to interact with the nginx pod. So kubectl run nginx hyphen image equals nginx should download the latest nginx image from Docker Hub repository and should create an nginx deployment for us. So kubectl get deploy should show that you have one deployment of nginx running in a system, and kubectl get pods hyphen -o should show that you have one pod running, that is worker 2, and the corresponding IP address assigned is 192.168.189.65, which means that it is basically conforming to the pod network CIDR that we had set of 192.168.00 by 16. You can now run a curl command to this 192.168.189.65 from a node within your cluster. That means you can go to either master 1, master 2, worker 1, worker 2 nodes and run a curl command. So I can just go to my master 1, master 2, any node of my choice. I'll run a curl over here to this IP address to see whether or not I'm able to connect, and I'm able to get the entire output from the Nginx pod. One thing to note over here is that you cannot run a curl command from the load balancer node, because ideally the load balancer node is not a part of your cluster. It just holds your load balancer. That means whatever Calico CNI that you have installed has only created a private subnet between master 1, master 2, worker 1, worker 2. That means you cannot run a curl command to the internal IP addresses which are local to only the nodes inside your cluster. Load balancer node will always be a node outside your cluster. So just to show you once again, a curl command over here will always get hung because this IP address block does not belong to the load balancer node. Just something to note. Especially if you are using cloud providers, you might have to open up certain firewall rules even to access these ports, access these IP addresses from the machines in your cluster. So just a side note on that. And guys, I believe we have completed this installation. So thanks for joining in for this demo of multi-master cluster configuration using Kubeadm.